All right, now that we have seen how these particular problems work with our perfect square trinomial and our difference of two squares, let's go do some new example problems together and see how this works. Let's test it out. So in problem number 1, we have s squared plus 16s plus 64. So let's ask our questions. Is this 2 terms or 3 terms? Oh, it's 3 terms. So if it's anything, it's a perfect square trinomial. Is the first term a perfect square? Yes, s squared comes from s squared. And 64 comes from 8 squared. Okay, so they're both perfect squares. So now we've got a plus sign right here in both of our locations. So that's what we're going to use in the middle of our binomial. S plus 8 squared. That quantity is squared. Done. Wasn't that great? I didn't have to do the X method or anything. I mean, the X method is totally going to work. It will work. You'll just do a lot more work and spend a lot more time on it than necessary to get to the exact same place. Let's look at number 2. So in number 2, how many terms do I have to work with? 2 terms or 3 terms? 3 terms. All right, so that means this will be a perfect square trinomial if it's anything. So here's my first term. It is d squared, so that came from a d. Yeah, that's easy. And my last term, that's a 25. So it came from 5 squared. All right, so depending on whatever that sign is right there, the first one, that'll be the determining factor of what sign is in the middle of your binomial. So now I have d minus 5 quantity squared. Done. Isn't that fabulous? All right, you get to pause the video and try number 3 and number 4. If you need some help, let me know. Okay, let's try number 6. So here on number 6, I've got the difference of 2 squares. That's what I'm told to do. But I know that because these are 2 terms and there's a minus here in the middle. And you might say, but wait. Neither of these are perfect squares. What? How? And I would say, you're right, they're not. But something that we talked about in the last lesson is sometimes all of the terms are divisible by something the same. There's a greatest common factor. And there's one here, so we need to use it. 50 and 8 are both divisible by 2. They're both even. So 50 divided by 2 is, 25. N squared minus, and 8 divided by 2 is 4. Aha! 2 terms, a minus in the middle, and these are now perfect squares. We're good to go. We just have to remember, bring the 2 with us as we work through the set. And we would say, oh yeah, I remember. 25 comes from 5 squared. 4 came from 2 squared. So this will be 5n, 5n. We have a plus, we have a minus. 4 came from 2 and 2. Done. There you go. And again, we could have used the X method and we would have come to the exact same conclusion of an answer for this factoring process. It just would have taken more time. And so if you don't remember, if you don't realize, oh, this is a perfect square, or if it's a difference of squares, yeah, you can always use the X method and that'll be fine. It just might not be quite as fast. All right, your turn. You get to do number 5 and number 7. Let me know if you need some help.